For each of the problems 1 through 4, we are dealing with the same region, just rotating it around different axis of revolution each time. So for this first one, we're looking at x equals y cubed. That's this graph. X equals 8 is the green one. And y equals 0 is basically the x-axis. So those are the three curves that we're dealing with. And those three close off this highlighted region. And it says to find the volume of the solid by rotating this region R about the following lines using shells. So that's the key here, is that we have to use shells. So one thing we need to keep in mind is shells are parallel, right? The rectangle that we draw, determining our dx or dy cut, that rectangle has to be parallel to the axis of revolution. So for this first one, we're going about the line y equals 4. It should be up here. So that's what we're rotating our region about. Since that's a horizontal axis of revolution, that means the rectangles we're dealing with have to be horizontal rectangles. And in this region, if we weren't told to do shells, we could use a dx cut or a dy cut. Either one would work in this highlighted region. But since we're told to do shells, we're going around the horizontal axis. Our rectangles have to be horizontal, which means we're going to have a dy cut, which tells us everything is going to be in terms of y. Now let's take a look at where our parts are: average radius, height, thickness. It may help you to draw just our axis of revolution. We've got a rectangle, and I'm going to draw another rectangle same size on the other side of that axis of revolution, and then connect them to see the shell that is created. All right, so we create this shell by rotating that rectangle all the way around that axis. And the rectangle that we're actually dealing with is this one down here. So the average radius goes from the axis of revolution down to that rectangle. All right, that's our average radius. So it's going to go from here down to here. All right, our average radius. The height of the cylinder, of that shell, is going to be basically the height of that rectangle. It's kind of on its side, but this is going to be our height. And we know the thickness is always going to be either dx or dy. So there's three things we need: average radius, height, and the thickness. We know the thickness is going to be dy, which means everything else has to be in terms of y. Now when we rotate it around just the x-axis or y-axis, our average radius is always just either x or y. But when we rotate around a line, it makes it a little bit more complicated, but not much. This time, we're going around this axis, and here's our rectangle, right? So this is our distance. It's a y value, right? It's a vertical distance, so we're dealing in y. So we have to take the top value minus the bottom one, right? The top one's bigger, bottom one's smaller, so if we subtract those, we get a positive value. So basically, we're taking the top value, which is the axis of revolution, minus the bottom value, which is just going to be the y value of the graph. All right, so the y value of the curve. Since it's a dy cut, we can just leave it as y. We don't have to substitute anything in terms of x. So the y value of this axis of revolution is 4, minus the y value of the graph is just y. So our average radius is 4 minus y. The height is this horizontal distance. So really it's kind of like an x value, right? Horizontal is x. We're going to take the right x value minus the left x value. Well, the right x value is just this line, minus the x value of the curve. Well, the line is x equals 8. The x value of the curve, well, we can't leave it as x because everything has to be in terms of y. If we look at the equation, remember x equals y cubed. Right, I've got it written right here. So the x value there is the same as y cubed. Now it's written in terms of y. So we have our three parts that we need. We're going to have 2 pi times the definite integral from a to b, we'll figure that out in just a second, of the average radius, 4 minus y, times the height, 8 minus y cubed, times the thickness, dy. So our a and b, we need the lowest y value, biggest y value. Kind of easy to tell from this graph. Our lowest y value is 0. From that line, y equals 0. The highest y value, since this is an accurate graph, we can kind of tell that's going to be 2. But let's say we don't have a nice graph like that. To figure out where those intersect, we're basically just finding the intersection of x equals y cubed and x equals 8. We need to know when those are equal to each other, so we would just set 8 equal to y cubed. Take the cube root of both sides, y has to be 2. So that's how we know that upper limit is 2.